All right, here we're looking at factoring, and factoring really at its core is really just the reverse operation of our distributive property. All right, so when you think about our distributive property, if we have a number being multiplied on the outside of the parentheses, what we do is we multiply it by everything inside the parentheses. So we're multiplying it into something, and then factoring is just the reverse of that. We're dividing that thing back out. All right, so distributing is multiplying in, factoring is dividing out. So it's kind of these reverse processes where we're just trying to undo what we did with our distributive property. Okay, that's what factoring is. All right, the first way we look at it for factoring is just factoring out the greatest common factor, or the GCF. And remember, the greatest common factor is just the largest thing that divides evenly into everything that we're looking at, okay? Into each of the terms that we have, all right? And so when we're talking about numbers, it's the largest number that divides evenly in there. When we're talking about variables, it's the largest variable that we can divide out as well, okay? So for example, when I look at this first one, here I've got a 2x to the 5th plus 6x. If I want to factor out the greatest common factor, between the 2 and the 6, the largest number I can divide out is a 2, so I write the 2 down. Between an x to the 5th and an x to the 1st, really I'm trying to divide out the most x's I can. And so if I have 5 x's with the first one and 1 x with the second term, the most x's I can take out of both would be 1 of those x's. So I'm going to take out an x to the first. And now what I'm going to do is I'm going to set up my parentheses. So again, it's just the reverse of the distributive property. Instead of multiplying this thing in, we're now dividing it out. So we're putting it on the outside of parentheses. And now I just divide it out of each of these. So I take this first term, the 2x to the 5th, and I divide it by the 2x. And when I do that, 2 divided by 2 is 1. X to the 5th divided by x to the 1st, I subtract the exponent. It's going to leave me with an x to the 4th. Okay? And then I do the same thing with the second term. I take the 6x and I divide it by the 2x. And when I do that, the 6 divided by 2 is a 3. And the x divided by x is an x to the 0, which is just 1, so I don't need to write that. So I'm just left with this inside my parentheses. So this is my factored form when I factor out the greatest common factor. When I look at this next one, again, I'm factoring out the greatest common factor, so I'm looking for the largest thing that divides evenly into each of these. And so as I look at the numbers, the largest number that I can divide out evenly is a 3. When I look at an x squared, an x to the 4th, and x to the 6th, the most x's I could take out of all three of these would be an x to the 2nd, because they each have at least 2. And now I'm just going to divide that thing out. So the 9x squared divided by the 3x squared is going to leave me with a 3. The negative 3x to the 4th divided by the 3x squared is going to leave me with a minus 1x to the 2nd. Again, the rule here is we divide the coefficients, we subtract the exponents. And now the 12x to the 6th divided by the 3x squared is going to leave me with a plus 4x to the 4th. Okay? And then the last thing we might do with this is, as we look at that trinomial that's inside the parentheses, I'm just going to go ahead and rewrite that in descending order, because this is kind of an awkward way to have this written. So I'm going to write it as the 4x to the 4th minus the x squared plus 3. And that's the way I'm going to leave this thing. If I look at the next one, the greatest common factor between a 3x and a 7y, well, really there's nothing that I can really take out here, but keep in mind that I can always divide out of 1, so the greatest common factor is 1, and if I divide that out, it leaves me with a 3x plus 7y. But of course, I would never write it this way. Because it's only divisible by 1, what I say is that this one is actually prime. And that makes sense because when you think about prime numbers are numbers that are only divisible by 1 in themselves. And that's what's happening here. It breaks up into multiplication of 1 times itself. So it's a kind of a prime factor. It's important, though, to understand that you can still factor a 1 out. All right, because there are situations where even if it's just a 1, we'll have to factor something out, and we'll see that momentarily. If I look at this next one, again, the greatest common factor here as I look through between the numbers is going to be a 2. And then because that minus 4 doesn't have an x, that's it. I can just factor a 2 out. That leaves me with an x squared plus 3x minus 2. And that's really all I can do for this one. This one doesn't factor any further. Okay? Next, we're going to look at factoring by grouping. And factoring by grouping, basically what we do is we put the terms in groups, all right? And typically, we're going to put them in groups of 2. So I'm going to put them in groups, and I just use parentheses to do that. I just kind of section them off. Again, typically, this is groups of 2, all right? So we'll make a note to self. There are certain situations where you want to do groups of more than 2, maybe 3 or 4 or whatever. But for our purposes, most of the time, we're going to be doing groups of 2 here. Okay, so keep that in mind. And we just use parentheses to section them off. Then what we do is we factor the greatest common factor out of each group. We basically look at each set of parentheses and we do what we did on the previous page. We just factor out the greatest common factor. This is just like the problems we just did, but we're going to have more than one problem to do within the context of each of these examples. Okay? After we're done factoring the greatest common factor of each, then we look for common polynomials. In other words, we just scan this thing and look for big chunks that are exactly the same, and then I'm going to factor out those big chunks as well. All right? So here's what this looks like. As I look at this first example, here I've got 4 terms. I'm going to put them in groups. So I'm going to put them in groups of 2. So I'm going to group the first 2 together and group the second 2 together. And notice right here, when I group these second 2 together, where that plus sign goes, the signs that are in front of these things kind of are attached to this number, and they tell us whether the number is positive or negative. So make sure you include the sign in there with the term, okay? So this way we know if it's positive or negative, because that's really going to help us when we go to factor these things, all right? So now if I ignored this second group, if I just ignored this guy for a second and just looked at the 3n to the third minus 12n squared, if I told you to factor that binomial, we would just factor out the greatest common factor. The greatest common factor here is a 3n squared. And when I divide that out, it leaves me with an n minus 4. And now what I'm going to do is I'm going to say, okay, let's look at this second group, and I'm actually going to ignore the first group. So if I were to ignore this first group and just look at the second binomial, 2n minus 8, I'm going to factor out the greatest common factor. Here it's a positive 2. And again, just like we included the sign inside those parentheses, I've got to include a sign here to tell me if this is positive or negative. So since I'm factoring out a positive 2, I'm going to put a plus 2. All right? And when I divide that out, it leaves me with an n minus 4. So now, as I look at this thing, now I'm going to scan across for big chunks that are exactly the same. And we see one big chunk that's exactly the same, this n minus 4 right here. Okay, so I've got this big chunk that's exactly the same. So what I do is I kind of factor out that big chunk. I take it from these 2 locations and I rewrite it over here at 1 location. So basically I factor out this n minus 4. So I write the n minus 4 down on the outside. And if I were to divide out that n minus 4 out of each of those big chunks, in other words, if I were to take the n minus 4 out of this piece and take it out of this piece, you can see that I'm left with the 3n squared and a plus 2. Well, that's my other factor. All right, so if I were to take out that big chunk, it leaves me with a 3n squared plus 2. All right, and really what you should see here is this is the reverse of our distributive property. Okay, this is what we do when we FOIL these things. If I were to take this thing, let me rewrite it this way. Think about what the process is that we're showing here in reverse. I'm writing m's instead of n's. I know my letters. So what happens here is if I were to FOIL or distribute, I would distribute this guy, which would be like me doing 3n squared times the n minus 4. I'm going to distribute it to that. And then I would distribute the 2. That would be like me doing the plus 2 distributed to the n minus 4. And then I would actually do the distribution. And it would leave me with a 3n cubed minus 12n squared plus 2n minus 8. And so you can see literally these reverse processes right here. If you look at step 1 here, matches step 3 down here. Okay, and step 2 matches this middle step. And so this last step matches this step. All right, it's literally the reverse of us doing our distributive property or FOILing. Okay, that's what factoring by grouping is. It's us undoing multiplying out 2 binomials. Okay, so the factored form of this thing is right here. And the other thing that this tells us is that we can easily check these answers by just multiplying it back out and see if we get to the original answer. Okay. If I take a look at the next one, if I approach this the same way, again, I'm going to group these. So I group the first 2 together, group the second 2 together. Out of the first 2, I can factor out a 4x cubed. So that leaves me with an x minus 2. Out of the second group, it looks like I can factor out a positive 12x, so I write a plus 12x. Again, that leaves me with an x minus 2. And now I can see these 2 big chunks that are exactly the same. So I'm going to factor out the big chunk, and it doesn't matter what order we write this in. If we write the x minus 2 second, and then we write what was going to be left, the 4x cubed plus 12x, that's fine as well. All right, so just keep in mind, we can write this in any order. However, there's an issue with this final answer. I can't leave this thing this way. All right, and the reason for that, as we look at this first binomial, the issue is right here with this first guy. that first binomial still has a greatest common factor left in it, so I have to factor out that greatest common factor. It has a greatest common factor of 4x. So I have to factor out that 4x, which leaves me with an x squared plus 3. And then this second binomial is kind of just tagging along for the ride. It remains unchanged. This is my final answer. So again, you have to factor out everything completely, which means you can't leave any greatest common factors lying around. And when you look at the original problem, the thing that's interesting about this original problem, when you look at each of these terms, they all have a greatest common factor of 4x. So what that tells us is that there's another way we can actually approach this problem. I could factor out the greatest common factor first. And here's what that would look like. If I start by factoring out the 4x out of each of these, that's going to leave me with an x cubed minus 2x squared plus 3x and a minus 6. Okay? And now look at what's in the parentheses. Now we're going to do factoring by grouping with what's left. So I'm going to group these two together, and I'm going to group these two together. This 4x is just going to kind of tag along for the ride this entire time. Out of this first group, I can factor out an x squared, which leaves me with an x minus 2. Out of the second group, we can factor out a 3, which leaves me with an x minus 2. And so now what we see here, again, this 4x just kind of tags along for the ride. Inside here, I can see my two factors. The x minus 2 is one of them. And the other factor is right here, the x squared plus 3. All right? So it's really up to you whether you want to factor the greatest common factor out first or wait till the end. In my opinion, it's always better to look for it first because that'll lead us to some shortcuts down the road, okay? So always look for the greatest common factor first, and then look for it again at the end to double check your answer, all right? But you can see we get the same thing either way, okay? If I look at this one, again, I scan across. There's no greatest common factors between any of these, so now I group them. I group the first two together. I group the second two together. And out of the first two, I can factor out a 3x squared. That's going to leave me with an x plus 3. Out of the second group, you have to factor something out, whether it's a 1 or a negative 1. In this case, it's going to be a negative 1. So I'm going to factor out a negative 1, which leaves me with an x plus 3. And really, anytime I see a negative in front of this first term in the second binomial, I'm going to factor out a negative. Typically makes things easier. And so for this one, I factor out that negative, and you can see right away that it gives me that same binomial in my parentheses. If I factor out and I don't get the same binomial, I can't do anything else. So I kind of want to get the same binomial if I can. All right? And so for this case, I had to factor out a negative. And so now my two factors, I can see them. It's the x plus 3 as one of them. And then if I were to take away that x plus 3, I'd be left with an 3x squared minus 1. Okay? And that's factoring by grouping. With factoring trinomials by grouping, and that's what we're going to do here, we're going to take the trinomial, and basically factoring by grouping required us to put these things into groups of 2 using parentheses. So when you think about a trinomial, I've got 3 terms here. Well, that's no good for factoring by grouping. So I have to transform this thing a little bit so that factoring by grouping works so that I can put things in groups of 2. All right? So here's what we do. We build a bridge, and that's not really a technical term. That's just an easy way to remember this. What we do is we take the first coefficient and the last coefficient, and we multiply them, okay? So we multiply the first and the last coefficients, okay? And that's what I mean by build a bridge. Take the first term and the last term, essentially, and multiply them. Except we just look at the coefficients, all right? Then we're going to find 2 numbers that multiply together to give us the number that we got from the bridge, okay? So the number from step 1, but add together to give us the middle coefficient. And really, we're just trying to get so in these 2 steps, we're getting all 3 terms kind of involved. We do first coefficient times last coefficient, which gives us the bridge. So we need 2 numbers that multiply together to give us that, but add together to give us the middle coefficient. So now we're using all 3, all right? After we come up with those 2 magic numbers that multiply to the bridge but add to the middle coefficient, we're going to rewrite the middle term using those values as coefficients, okay? So basically what I'm going to do is I'm going to take this trinomial, I'm going to come up with these 2 values, and I'm going to split the middle term into 2 separate terms. And you see the effect that has when I look at these first 3 steps is basically I go from 3 terms to 4 terms, okay? So instead of having a trinomial, I rewrite that middle term as 2 separate terms. Now I have 4 terms, which allows me to do factoring by grouping. Once I have 4 terms, I can put them in groups of 2, all right? So I build a bridge, first coefficient times the last coefficient. I come up with 2 numbers that multiply together to give me the bridge, but add to the middle coefficient. And then I rewrite the middle term as 2 separate terms, okay? So now I have 4 total terms. I can do factoring by grouping, all right? So here's what this looks like. if I look at something like this guy, again, build a bridge, I'm going to take the first coefficient and the last coefficient, so the 2 times a negative 6, which is a negative 12. And now I just need to come up with two numbers that multiply together to give me that bridge, the negative 12, but add together to give me this middle coefficient right here, which is a positive 1. Okay? And so the two numbers that multiply to a negative 12 but add to a positive 1 are a 4 and a negative 3. All right? So now here's what I do. I'm going to split up this middle term. Instead of having this as a 1x, I'm going to rewrite it as a 4x and a minus 3x, because that's the same thing. All right? So I'm just going to split up that middle term into two separate terms. That x is now going to be a 4x and a minus 3x. And everything else just kind of tags along for the ride. So essentially, I'm just rewriting this trinomial, but I'm rewriting the middle term as two separate terms. Okay? And now we see the effect that has. Now, I can do factor by grouping. Now I can put them in groups of 2. So I group these two together, I group these two together. Out of the first group, I can factor out a 2x, which leaves me with an x plus 2. Out of the second group, I can factor out a negative 3, which leaves me with an x plus 2. And now I see these two polynomials that we have in common. So my two factors are the x plus 2. And then when I factor that out, I'm left with a 2x minus 3. All right? And again, this is literally the reverse of our distributive property with binomials. Okay? When we multiply out these two binomials, I would distribute each piece. Then I would combine like terms, the 4x and negative 3x, and bring us back to the 2x squared plus x minus 6. All right? So I build a bridge, I split out the middle term, I factor by grouping. If I do the same thing with the next one, again, I build a bridge. 4 times 5 is a 20, positive 20. And two numbers that multiply to a positive 20 but add to a positive 12 are going to be a 10 and a 2. So now I split up the middle term, so I rewrite this as a 4x squared plus 10x plus 2x plus 5. Okay, so it's the same thing, I'm just rewriting the middle term as two separate terms so that I can group these. So I do factoring by grouping. I group the first two together, and out of that I can take out a 2x, which is going to leave me with a 2x plus 5. Out of the second group, remember with factoring by grouping, we have to factor something out, and the only thing I can factor out here is a positive 1, which doesn't change anything, it leaves me with a 2x plus 5. But it does allow me to see these two factors. See, now I have this guy in common. So one of my factors is the 2x plus 5. The other factor is what would be left when I take that away, which is the 2x and the plus 1. All right, so again, I build a bridge, I split up the middle term, I factor by grouping. Same thing with the next one. Again, I build a bridge. That gives me a negative 12. Two numbers that multiply to a negative 12, but add to a positive 11. Well, that's going to be, let's see, that's a 3x squared. Oh, sorry, I forgot to write the terms down. That's a 12 and a negative 1. So I'm going to write that as a plus 12x and a minus 1x minus 4. And now I can do my factoring by grouping. So I group the first two terms together. I group the second two terms together. Out of the first two terms, I can factor out a 3x. Change back to blue here. So I factor out a 3x. That leaves me with an x plus 4. Out of the second two terms, I have to factor something out. This time it's going to be a negative 1. And now from here, I can see the two polynomials that they have in common. So one of my factors is the x plus 4. The other factor is what I would be left with, which is the 3x minus 1. Okay? So again, build a bridge, split up the middle term, factor by grouping. And now this next one, I could build a bridge and split up the middle term and factor by grouping, and that would be fine. It'll work out okay. But notice here that I have a greatest common factor of 2 with each of these. So I'm actually going to factor out the greatest common factor first because it makes things just a little bit easier in the long run. So I'm going to factor the 2 out. That leaves me with an x squared plus 2x minus 8. And the reason we want to get in the habit of doing this, because we'll have some shortcuts that we can do later. Inside here, I build a bridge. The two numbers are going to be a positive 4 and a negative 2. So I split up the middle term. Again, this 2 is just going to kind of tag along for the ride. So I'm going to rewrite this as a 2x squared plus 4x minus 2x minus 8. And now I can do my factoring by grouping. So I group the first two terms together. I group the second two terms together. Out of the first two terms, I can factor out an x, which leaves me with an x plus 4. Out of the second two terms, I can factor out a negative 2, which leaves me with an x plus 4. So now I can kind of see my two factors in the parentheses here. My two factors in the parentheses are going to be the x plus 4 and the x minus 2. But then this 2 that's kind of been tagging along for the ride just keeps on tagging along for the ride, and that's it. All right. If we build a bridge from the start, split up the number determined factor by grouping, we'll get the same thing, except we'll end up with that 2 stuck in one of our binomials, and we'll have to finish factoring. So always look for greatest common factor at the beginning of the problem, and then always check for it again at the end of the problem. Okay?